Hey everybody, we're taking a look at this expression and we're looking at the expression vocabulary. So we want to be familiar with the words term, factor, sum, and coefficient. And I know we've covered this before. So as you look at this activity, here's our expression. It says 5 times m plus 4 in parentheses plus 3p. So we want to examine that, and you'll see that same expression is written for us here. And I'm not sure why I decided I'd cover up the 5, but that's an important letter. So when I look at that, I want to try to figure out, first maybe I'll look at my terms. And I know that a term is separated by a plus or a minus sign. So I can almost make like a little invisible barrier here to separate out my terms. Now I can't put a separation here for this plus sign because it's in the parentheses. So when I look at these, I look at the 3. Is 3 by itself a term? I'd say no. And then m plus 4 by itself, not a term. 5 by itself, not a term. 5m plus 4 is a term. So I'm going to go ahead and put a little check mark there. You might put an X or whatever it would be. Let me go do the same thing here with factors. Now a factor is something that's multiplied by something else. So I can think of X factor because I know X means multiplication in math. So is 3 being multiplied by something? Well, there it is. It's being multiplied by P. So yes, 3 is a factor. It's a really poorly drawn check mark for you. M plus 4 as a parenthesis, as a group. Is m plus 4 being multiplied by anything? Here it is here. Well, yes, it's being multiplied by 5. So m plus 4 is a factor. Same thing with 5. If 5 is being multiplied by m plus 4, then m plus 4 is being multiplied by 5. They're both factors. And then finally we have 5 times m plus 4. So this is a little bit tricky because yes, there's multiplication going on in that problem or in that part of the expression, but I can't say that 5 times m plus 4 is actually being multiplied by anything else. So that is not a factor. Let's do the same thing for sums. So I'm going to put a little plus sign here so I remember that a sum is an addition problem. So I have a 3. Is 3 an addition problem? No. Is m plus 4 an addition problem? Why, yes, it is. Is 5 an addition problem? No, it's not. Is 5 times m plus 4 a sum? Again, kind of tricky because there is a sum in there, but 5 times m plus 4 is not a sum. Let's take a look at coefficients. Now, I told you this the last time we did this problem here. If something is a coefficient, then it's definitely a factor. But if it's a factor, it doesn't necessarily mean that it's a coefficient. So we know that there's 3 options. I can automatically say that this is not a coefficient. That is a term. It's not a coefficient. So let me look at them. 3. Here it is, right here. 3. Is 3 a coefficient? Is it multiplying? Is it being multiplied by a variable? And yes, it is. The variable is p. Is m plus 4 a coefficient? Is it being multiplied by a variable? My answer is no, it's not. Is 5 a coefficient? Is it being multiplied by a variable? This one's kind of tricky. Think of the parentheses here as its own separate variable part. So when we think of that, we know then that 5 actually is a coefficient. So that's the first part here. And then for numbers 5 and 6, we're combining like terms. So here they are down here. What I'm going to do is try to make a shape here. I'm going to change up my line so it's not quite as thick. And I'm going to maybe put a circle around all of my k's. So let's see if I can do that. I have a 7k. I have a k alone. I have a 2k. I have a k alone. I have a k alone. And I have a 5. Now I can't put a circle around the 5, so I'm going to put maybe like a box around my 5. Okay, so now I'm going to combine like terms. So what that really means to me is I'm combining my shapes. All right, so all my circles can be combined. So I have 7k plus 1k, because there's an invisible 1 as my coefficient. So 7 plus 1 is 8, plus 2 is 10, plus 1 is 11, plus 1 is 12. So my answer here is 12k plus, and here's where I can combine all of my squares, which there's only 1. That makes it easy, 5. I apologize for my poor mouse writing right there, but that's actually not too bad. You can read it. Next up, we have 7 plus a plus 12 times 7 plus a. I want you to point out here that we have 7 plus a both times. That is the same variable part or an identical variable part, which means they're like terms. So we can think that there's a invisible 1 here as a coefficient. So I have 1, 7 plus a, and then I'm going to add that to 12 7 plus a's. So I used the example before. If I had, like, let's say 12 7 plus a's in my hand over here, and then out of the air I grab another 7 plus a and I put it in my hand, I now have 12 plus 1 7 plus a's. That's going to give me 13, and then I'll use that 7 plus a. That's a plus sign. That's supposed to be an a. Oh, okay, mouse writing. There we go. All right, so now is kind of the part where we extend this. So yes, it's 13 times 7 plus a, but we can use the distributive property to distribute my 13 over to my 7 and over to my a. All right, so what that means is I'm going to take 13 times 7, and I don't know what that is, so look at me multiplying. That's a multiplication sign, by the way, with my mouse writing. 7 times 3 gives me 21. 7 times 1 is 7, plus 2, that gives me 9. So 13 times 7 is 91, plus what happens when I have 13 distributed to the a? That's 13 times a, which is 13a. There we go. So I apologize again for the bad mouse writing, but check your work right now. Make sure that you have the answers down that I have. I'm going to scroll up one more time just to make sure you've got our table. And then I will wish you adieu.